Hello, today we're going to be talking about rotations. And first things first, what we need if we're going to find a rotation, well, we need the rotocenter, which is the point you're going to rotate around. And then you need your angle and direction of rotation. So how far you are going to rotate, and then whether that is clockwise or counterclockwise. And let's go ahead and dive right into an example. Okay, so we've got a bunch of points over here, and we want to find three different things. So we want to find the image of B under a 90-degree clockwise rotation with rotocenter A. Okay, so we've got the point B here. We're rotating around A, and we're going to take this B and rotate 90 degrees clockwise. And when we do that, the distance between the rotocenter and our point stays the same. So we were 3 units away out to the left. When we rotate over, we're going to be 3 units up, and that ends up right at I. All right. Now we want to find the image of A under a 90-degree clockwise rotation with rotocenter B. So we've switched them around. So now B is the center, and we're rotating A 90 degrees, and we're going clockwise. So we're going to go like this. A started 1, 2, 3 units away, and it ends up 1, 2, 3 units away right at G. And the last one, we want to find the image of I under a 3,690-degree clockwise rotation with rotocenter A. That sounds very complicated. But remember, 360 degrees clockwise, well, that's just going in a whole circle. If you rotate 360 degrees clockwise, you end up right back where you were. So what we can do is think about this, break it into a multiple of 360 and then something else. Well, we can break this into 3,600 plus 90. Well, 3,600, right, that's just 10 times 360 plus 90. So it's 10 full rotations plus 90 degrees, and we're going clockwise. So I is going around A 10 times back to where it started, and then 90 degrees clockwise. It started off 3 units away, ends up 3 units away, right at E. Okay, let's do our next example. Find the image of this little tetracene shape here under a 180-degree rotation, and we're going to assume our rotocenter is the origin here. Origin, or where those axes cross. Okay, so 180 degrees. We should note here we don't have a direction, but 180 degrees one direction and 180 degrees in the other direction is going to end up in the same place. So whenever it's 180, you don't actually need clockwise or counterclockwise because it doesn't matter. So I'm going to think about going clockwise. Okay. And what I'm going to think about is, right, let's just start thinking about this little point here, this corner. Well, it was 3 units to the left and 1 unit down. So when I take that and flip it over, it's going to be 3 units to the right and 1 unit up. And now this one, right, it was out to the left 1 unit. But when we do a 180, that's going to be out to the right 1 unit. And similarly with these two pieces here, they were down 1 unit, but when we flip that over 180, they'll be up 1 unit. This was to the left, but when we rotate it 180, it ends up to the right. This was to the right, but when we rotate it 180, it ends up to the left. And then we've got this piece here, right? This little pokey part coming down. It was pointing down on this right side, but when we rotate it up, it's going to be pointing up on the left. And then we fill in the rest of it. Was going off to the left, now going off to the right. And we've got that 180-degree rotation of our little Tetris shape. Let's go ahead and do one last example. This time, we don't have information about the rotation. We don't know the rotocenter or how far they were rotated, but we do know that Q started here and under the rotation ended up here. P started here and under the rotation ended up here. Okay, so what we want to do is find the rotocenter. So what we're going to do is look at the line segments between Q and Q prime and P prime, and the rotocenter is where the perpendicular bisectors of those line segments intersect. And we saw the perpendicular bisector in the last video. So here, let's draw one of our line segments. And let's draw the other line segment. And perpendicular bisector is just a fancy way of saying find the midpoint of your line segment. Here's one midpoint. Here's the other midpoint. And draw a perpendicular line to it. So at a right angle. And I'm going to do my best in this video to draw some straight lines. Whoop, here's one perpendicular bisector. And here's the other perpendicular bisector. We already have their intersection point, so we don't need to go any farther. So that point is our rotocenter.